Okay, I have some good news and I have some bad news for our lecture today. So the good news is this is our last lecture, well, not for me, maybe for you, of online business calculus. This is our last section we're going to cover. The bad news might be that this is kind of a long section. So we'll see how long I go on this video. I might break it up into two parts. But this is a really important topic that we're going to talk about today, and it's pretty cool, especially if you're a business major or interested in business, which hopefully you are if you're taking this class. Um, hopefully this will be kind of interesting to you. And I hope you've read through the section, but I know that it can be kind of tough. So I'm going to actually be kind of going through some of the examples that they do in the section, not all of them, but I'm going to follow pretty closely how your book describes this idea of elasticity of demand. Okay, so this is a pretty cool subject. I'm not a business person, but I like it because it has to do with some pretty neat mathematics. So let's go ahead and get talking about this. So if you look at the title of this section, it's Applications of the Natural Logarithmic Function to Economics. And the main concept we're going to talk about here is elasticity of demand. But before we get to elasticity of demand, what we need to talk about is this idea of the derivative of the log. And so what we're going to basically talk about, and they kind of title this in your book as relative rates of change. So this is a topic that I teach in, like a problem solving class. Okay, so a relative rate of change. So if I wanted to know like my relative rate of change of, well, we're not getting raises this year, but let's just pretend we were, of change. Let's say, okay, I don't make this much, but let's say that I make $100,000. I wish. That would be awesome. And let's say that my salary increases by 20,000. So what we mean by a relative rate of change is I'm looking at how did my salary change? That's what I'm going to put in the top versus what is my current salary now. So I would have 20,000 over 100,000. And that'd be amazing. So let's say I have a $20,000 raise all over 100,000. And this is what we mean by a relative rate of change, because my change in salary is related to my initial, the salary itself. So if I want, these always give us percentages, okay? Again, change in salary over my salary itself. So if I cancel these zeros, I can cancel this zero. I get 2 over 10, which is 1/5. Right? Which if I did that as a percentage, that would be, and this makes sense, 20%. And that's positive because it was an increase in my salary. So what does that 20% represent? That represents the increase in my salary, or I got a 20% raise. Okay? It's relative because it has to do with my salary. Now, if I was making, let's say I got a $20,000 raise, but I'm actually making $200,000, or maybe someone else got $20,000 also, but they're making $200,000. Then if we look at this, again, it's relative to the salary that that person is making. Now I get 1 out of 10. So even though we got the same amount of raise, right, because I make a smaller amount, that raise is a greater percentage of my salary. I got a 20% raise, whereas this person only got a 10% raise, but we got the same amount. So I hope that kind of makes sense. That's the idea of this, of a relative rate of change, and it gives us a percentage. So where we see that come in is when we take the derivative of, so again, remember, I know I keep repeating myself, but so much of math is repeating itself. This is my rate of change. So I'm going to say change in salary. So maybe delta. These little, I don't know if we've used this. I think we have. These little triangles, yes, that's a triangle. My 5-year-old knows that. These little triangles mean a rate of change all over my salary. So a relative rate of change would be the change in salary over my initial salary. Just want to remind you of that. Because what I'm going to be, oh, no, I need to go to green. Come on. I'm not OCD at all. If I take that, so the idea where this comes from, so it's a little bit of a long shot here to say that it's applications of the natural logarithmic function, but what we want to show is, and honestly, we're not really going to come back to this natural logarithm very much in this section, but what they're trying to show here is how do I take the derivative of the natural log of some function of t with respect to t? Okay, so what I would do in this case is I would take 1 over the stuff, right, which we know that's how we take the derivative of the natural log, 1 over the stuff all over times the derivative of the stuff. So if you look at this, the reason that this is interesting for us and the reason I talked about relative rates of change, was that look at what I have here. What does the derivative give us? That's right, a change, right? This is the change in f, right, with respect to time, divided by f itself at time t, which is just like what we have here. It's basically delta f, that's what the derivative gives us, over the function itself. They do a really nice example in your book, and it's kind of like stuck in this long paragraph on page 272. So I'm going to do this as an actual example for you, and then sorry, I'm copying a bit from your book, but I actually kind of like, so I don't always like what they do, but I like this one. So we're going to look at this idea of relative rate of change. Let's let f of t equal, these are a little bit strange, but whatever, price per pound of steak. Yum. My kids call cows steak. So whenever we drive by like a herd of cows, my daughter will be like, look, steaks, which isn't very nice probably, but it's kind of funny. We're looking at two very, very different things here. So let's let f of t be the price per pound of steak, and let's let g of t be the price of a new car. A new car! I keep thinking of like Wheel of Fortune. Did you guys watch that? You can't answer me because I'm not talking to you technically. All right, so we have the price per pound of steak. Let's g of t be the price of a new car, whatever car you want, whatever, doesn't matter. And let's let my initial price, okay, so at some point in time, I'm just going to call this t sub 0. We use that a lot for like the initial time. And let's say that my steak right now costs $5.25. And at this other initial time, right, we saw this when we talked about, you know, our initial population and stuff. That's when we had this would be that same idea, whatever time we decide to look this at. And, well, this new car is pretty cheap, so we're looking at a cheap car is $12,000, okay? So the question here is, if the price per pound of steak at that moment in time is changing by 75 cents, and notice that's positive, so that means it's increasing, and g primed of t at this moment in time, right, is changing by $1,500, which price is increasing more quickly? Which price is increasing more quickly? Because we got to think about this, right? We're dealing with steaks and cars, two very, very, very different things. So if you look at this, you could be like, well, Sarah, clearly $1,500 is more than 75 cents. And I would say you are absolutely right. But when we're dealing with steaks, right, versus new cars, we have to see, is the 75 cents more the impact of that bigger for $5.25, or is $1,500 a bigger impact when we're dealing with $12,000? Okay, so it's this idea of, again, a relative rate of change relative to whatever we are dealing with. So let me erase some of this stuff up here. So we have a nice, I don't want to change stuff. You know what I'm talking about. All right, so which one is changing more quickly? So again, so let's look at the steak. And if I want the relative rate of change at this moment in time, let's say t naught, I'm going to take f primed of t naught divided by f of t. Again, what is that saying here? That's the change in price of my steak divided by the actual price at this moment in time. And what is that moment in time? T naught. So in this case, I would take 75 cents. Right? That is the change I'm having. What was the initial amount for the price of steak? $5.25. And I get 0.143, which as a percentage says that the price of my steak is increasing by 14.3%. Okay, so that's how the percent increase of the price of my steak. Let's look at the car. So my relative rate of change here, g primed of t naught, all over g primed of t. Again, the change in price, oh, Sarah, you knew what I meant, it's just g of t. All right, so what is this going to equal? In this case, so yeah, $1,500 is bigger than 75 cents, but on the bottom I have 12,000. Okay, so this ratio here might be smaller, and we see that it is. You get 0.125, which is 12.5%. So even though 1,500 is much bigger than 75 cents, relative to what we're dealing with, price of steak versus the price of a car, which one is increasing more quickly? The price of the steak. So the price of the steak, oh, my handwriting today. Taking Christmas break off, I did not practice, is increasing. Hopefully you can still read it more quickly. All right. Okay, then, and I should finish it, but I don't want to write it out. Then the price of the car. So that's the first part of this section. It's just this idea of a relative rate of change. And where we are going to deal with this is this idea of elasticity of demand. So I would encourage you look at the example 1. They do another example, and even example 2. Go ahead and look at those examples in your book on page 272. And you can see more examples of how to use this relative rate of change. But I would like to spend the rest of the time chatting about this idea of elasticity of demand. And again, I'm going to pretty much just kind of follow your book here. So if you've already read through it and totally understand it, you can skip forward if you want to an example. But I'm actually going to do a bit more of a lecture in this section than just examples, because this is a pretty important concept, okay, and it will be on the final. So I know you care about that. All right, so here's the idea of elasticity of demand. Here's what our question is when we're dealing with elasticity of demand. So my question is, how does a change in price impact quantity demand? Okay, so we are going to be looking at, let me finish writing. Oh, my handwriting today. How does a change in price impact quantity demand? So what we're looking at today is we're going to basically look at a system, like I'm selling something maybe, and I want to know what would happen if I increased price. What would that happen to my demand? I know usually it decreases, right? But if we look at that, if an increase of price, so how might that affect my demand? But then maybe my revenue will be okay too, right? So we have this whole thing tied in together. Well, if I increase price, my demand might go lower, but I'm getting more money for each quantity that I sell. The other question is, if I lower my price, what will that do to demand? It will probably cause my demand to go up, but what does that mean for my revenue, right? I'm still decreasing prices. So even though I might be selling more, I'm not taking in as much money. So it's this whole idea of looking at this kind of system, right? This economy, very, very small, on a small level, what we're going to look at. But let's just start off with a simple actual example. So let's consider, and remember we've used these functions before. It was a while back, but let's consider the demand function. Okay, and what we used before was, so I'm going to do P equals 150 minus 0.01x, where P equals price, and we're going to call this X something else. I'm not quite sure why they do this, but, and X is the number of units, which we're going to call quantity later. And the demand thing here. So if we look at this, we say, what this is basically asking is, if we want to sell X number of units, if I want to sell 17 units, I don't know why I came up with 17, I would put 17 in here, and that would spit out what I should be charging for each unit. Now, what I want to do really quick is I want to solve this sucker for X. So I'm going to solve for X. So if I solve for X, let me show you how I would quickly do this, because sometimes algebra can be the hardest part. I'm going to actually switch. I'm going to take this guy and move it over, and I'm going to bring P over so that my X is positive. And then I'm going to divide by 0.01. But remember what 0.01 is. That's 1/100th, right? That's what 0.01 is. So what I'm actually going to do is I'm going to multiply both sides by 100. So I'll just call this 100 times 150 minus P. And you could take the 100 through. If you can't sleep tonight with that 100 out there, you go ahead and take it through. And then this is a little bit weird in your book, but instead of using X now, we're talking about quantity demanded. We're actually going to just replace X with Q. So the number of units, this is also the quantity. We'll just call this Q. And we'll also, in this case, notice that Q is a function of P, of price. So the reason I went ahead and solved for X, I guess I didn't say that before, is what I want to see is if I change my price, right? If I change P, what is that going to happen to my quantity? Okay, so what I needed to get my P as my independent variable and my X as my dependent variable. That's why we switched these two. All right, so this is our demand curve. Okay, notice this guy right here is just a line. If you rewrote this, if we actually did solve, this would be a negative 100p plus 150. 0, right? So this is just a line that has a negative slope. Now, if we look at demand, and if you're taking other business classes, you probably know this more than I do. If I look at my price here and my quantity here, if it wasn't linear, what we really see is that it is at least, maybe it's not linear always, but it's definitely a decreasing function. So, oh my goodness. Sarah Louise is my mom. Oh, wow. I'm so sorry. This is not working. We're just going to go with it. Okay, so maybe we have something like this. Oh, I'm so sorry. That should be, I have to try one more time. You're like, come on, Sarah, just get it over with. I've been listening to you for 16 minutes now. Maybe you haven't. Maybe you've been pausing it. All right, so we have something like this. I apologize for that. And what we have is we usually have f of p is usually decreasing. Okay, so this is my function of price. And why? What does this make sense? Well, if this is my price function right here, if I have a lower price, ideally, right, we would think that we would sell more of whatever we're dealing with. And as I raise my price, as my price increases, right, then my quantity would decrease. So it makes sense that I have a decreasing function. So that's a pretty normal relationship in business. What we're going to look at is, well, what does that mean, though, about our revenue? Okay, so a couple other things here. So here's my function of price. What would the derivative of this guy mean? The derivative of this is the change in quantity, right? Obviously, because that is f of p is my quantity. But what is it with respect to? It's the change in quantity with respect to price, because I am deriving, right, with respect to p. So this is the interesting thing. I'm going to be using f primed when I talk about elasticity, and it's going to be talking about the change in quantity with respect to price. Okay, I need a new sheet here. Let's clear this guy out. Okay, whoops. I always do that. Do I do that every single time? You'd think I would learn by now. So here's the idea of elasticity. Okay, so we've kind of set ourselves up here. And here is what we mean by elasticity of demand, or price elasticity of demand. What we want to do with elasticity of demand is we want to compare, all right, the relative rate of change. So this is what elasticity is basically defined as. So the relative rate, which we had just talked about, right, of change of quantity. Okay, so we know how to do that. We do the change in quantity over the quantity, right? And I want to compare that relative rate of change of quantity demanded, we could say, I guess, or our demand. Okay, and I'm going to compare it with, okay, the relative rate of change of price. So when we say this comparing thing, we're going to be taking a ratio of these two. So look at the two things that I'm going to do compare the relative rate of change of quantity demanded, that's the top, that's going to be our numerator, with the relative rate of change of price. Those are the two things that I am going to be comparing, okay? So another way to say that, let me get my notes, because this is an interesting concept, and it's Not something that I should be cocky about, and I need to look at my notes. So another way of saying this, okay, is I want the percent change in quantity, the percent change in quantity, right? Just like we found the percent change in price of steak or the percent change in price of a new car. Now I want the percent change in quantity divided by the percent change in price. And I want to point out that this guy does not have units. Okay, so quantity would be like if I'm selling shoes, right? I would have 1,500 shoes. That's unit would be shoes. If I'm charging 17, I don't know why I keep being on 17, $17 per shoe, that unit is dollars. But when we look at here, this is a percentage which does not have any units. So it's a change in quantity over a change in price. This guy does not have any units. It's unitless. Poor thing. Okay, so how do we do this? Well, we know how to find relative's rate of change, right? We take the change divided by the actual function itself. So here's how we want to do this. So let's stick with our colors here. So let's find the percent change in quantity, right? The relative rate of change of quantity. Okay, so remember what our quantity function was. Our quantity function was this idea of f of p. And we'll come back to our example with the actual functions here in a minute. So my percent change in quantity then is going to be f primed over p, f primed of p divided by f of p, right? And this is all with respect to p. Another way I could have said that is d dp of f of p all divided by f of p, okay? Remember, that's a function of price. Percent change in price then? Well, for right now, we just know price is p equals something, right? So I'm basically taking the derivative with respect to p of p all divided by p. P isn't a function of anything. P is my independent variable. It's just like when I take the derivative with respect to x and I have y as a function of x. Then what is the derivative of p with respect to p? That would just be 1. And then this is all over p. Okay, so now we're ready to find this. So I'm going to figure out this fraction right here. And what we're going to call this is the elasticity or the price elasticity of demand. Okay, and this is again comparing these two guys right here. And how do I compare them? I put them over each other. So I'm going to have f primed of p all over f of p. That's my percent change in quantity all over my percent change in price, which would be 1 over p. And now that doesn't look very pretty. Remember, what do we do when we multiply or when we divide? When we divide by fractions, I multiply by the reciprocal. So the reciprocal of 1 over p, right, is going to be p over 1. Okay, and so what do we get here? We get p times f primed of p all over f of p. That, well, we're going to change one small thing here. That is what our elasticity of demand is. And here in a moment, we're going to add a negative onto this. So we're going to do a big definition here in a second. And I think I'm going to do part 2 here in a moment, but we're going to put a negative out front. So let's define this. Let's write down the definition, and then I'll split this video into 2 parts. So that's what my elasticity of demand is, and this is the formula that we'll be using to do that. Price times the rate of change of my quantity divided by my quantity, and that is the proof of it. So let's write that down a little bit better. So definition. And then I'll talk about, we're going to add a negative in here, and I'll show you why we're going to add a negative. Okay, so definition. You should write this in your notes. The elasticity, or the price elasticity of demand, we'll call this E of P at price P. So you have to be given a price, right? We have to know, so this is what I'm defining, at price P for the demand function. So you also have to know the demand function. Okay, Q equals F of P, excuse me. Right, my demand is a function of price, is defined to be, or is given by, that's how I like to say that. Okay, and so E of P, now we're going to add a negative in. Don't freak out about that. I'm going to put a negative P, or the other thing you can do is just take the absolute value, but that Q is really messing me up here. Negative P, I'll just write a little smaller, times F primed of P all over F of P. Cool, that's our elasticity of demand. Now, here's the thing. Why did we put the negative sign? Well, if we look back at, did I erase it? No, I didn't erase it. Okay, if I look back at this function right here, notice, what do you notice about the slope of this function? If I took all of my derivatives, right, f primed of p would be less than 0. It'd always be negative. And we want our elasticity to be positive, because look at what we're looking at is we're comparing, right? Elasticity of demand is comparing the percent rate of change of quantity with the percent rate of change of price. So I just want it to be positive because we're going to define some things about elasticity that's important. So we'll always have them be positive. Now, so because so again, I didn't actually explain this. Because f primed of p is always negative, we put in this negative sign right here so that when we take the E of P, when we find the elasticity, it's always going to be positive. So a couple of notes about this definition, and then I'm going to stop this video and begin another one. So a couple notes here. If I take E at some price point, we'll call it P naught, okay? If I take E at some price point P naught, and if it is greater than 1, what we say is that the demand is what we call elastic, and we'll talk about what that means, okay, at that price point, okay? If I put in a price point, P naught, or P sub 0, and it's less than 1, then what we say is that demand is inelastic at that price point. Okay, so if it's greater than 1, it's elastic. If it's less than 1, it is inelastic. And we are going to, I'm just looking over my notes here. I'm going to stop the video now, and I will start a new one to finish up this section.